Okay, so everybody has joined. 22 students are there. Okay, so shall I start? Okay. So, other as I already said, that the fresh sewage that it is your odorless, and if you keep the fresh sewage for 3 to 4 hours, then what will happen? It will become stale because the sewage, it starts decomposition. Okay, it starts decomposing, and so the fresh sewage it becomes stale. And what happens? The oxygen that is present in the sewage, it gets your practically exhausted. Okay, it goes out. So then, when your oxygen it is not present in the sewage, so what happens? It starts emitting your foul smells. Okay, and what is that foul smell? It is like that of a hydrogen sulfide gas. Okay, and also to estimate or to measure your odor, we have already discussed in your raw water engineering that there is one term called threshold odor number, if you can remember, as TON. So we have discussed about it already. So just a brief again, I want to repeat that what is a threshold order number? That it is it is the it represents, or it is the extent of dilution that is it is required to make the order sample odorless. Okay, suppose you are taking a sample of water, or sorry, not water, it's sample of sewage that is it is very odor. So how much that distilled water you should add to that odor sample, so that the odor sample it becomes odorless. So that extent of water or the dilution, it is known as your threshold odor number. Okay, then formula also already I gave you in your raw water engineering. So no, I don't think it's again required to explain. Okay, so this explanation, this Vs plus Vd, I gave you in the form of A plus B plus A. Okay, if you can remember, or if you go back to your raw engineering water classes, so you will get this formula. Okay, same thing here. So next is your temperature. So the temperature, it also it has an effect on the what biological activity of the bacterias that are present in the sewage, and this temperature, or in these bacteria, they affect the the gases, the solubility of gases in the sewage. Okay, and also the temperature, it affects the viscosity of the sewage, and then when it affects the viscosity, so it in turn it affects the sedimentation process and in the treatment. So temperature also, it has some it has an effect on the biological activity of the sewage. So next is your chemical characteristics. So physical characteristics are these five only. Okay, so not five, sorry, four. Four are the physical characteristics. So you these are very short, and you can easily remember. So you can note it down in your copy, all these things. Okay. So next is your chemical characteristics. Here also the same thing. Okay, all those pH and chloride content, nitrogen content, but some the 2 3 characteristics are different than that of your raw water engineering. So first one here, it is your total solids, suspended solids, and settleable solids. Okay. So what is total solids and suspended solids and settleable solids? First, let us discuss about this point. So in a sewage, this the sewage. I already told that it is sewage means that it is your 99%. It is of water, okay, or 99%, 99.9% it is of water, and it contains only your 1% or 0.1% or 0.05 to 0.1% of your solid or total solids. Okay, so these solids, okay, that is present in sewage, it can be of four types. Number one is your suspended solids. Number two is your dissolved solids, then colloidal solids, and your settleable solids. So what is the suspended solids? From the name itself you can get an idea that the solids which remain floating in the sewage, okay, the solids that remains floating in the sewage, it is known as your suspended solids. Then dissolved solids, obviously, from the name itself, you can make it an idea that dissolved solids are those which remain what dissolved in the sewage, just like in just like your salt dissolves in water. Okay, that means you cannot see that. So that it gets dissolved and you cannot see that which are magnetized. So that is your dissolved solids. Okay. Then colloidal solids are what? Colloidal solids, they are they are solids that remains either in suspension, or it might get dissolved also. Okay, so it might be either in a solution or in a suspension form. So that is your colloidal solids. And number four is your settleable solids. So what is settleable? So if you keep the sewage sample for 2 to 3 hours, so what will happen? The solids that which settles down. Okay, you can see the solids that is settling down at the bottom of your whatever water bottle or whatever in whatever tank you are taking. So you will be able to see the solids that are being settled, which is known as your settleable solids. Okay, so again, you can say that the solids it it comprises of organic as well as inorganic solids also. Okay, the sewage in the solids that are present in sewage, it also comprises of what? Organic as well as your inorganic solids. So what are the organic solids? It works out to be 45% of the total solids. So 45% of the total solids are your organic solids, and the remaining 55% are your inorganic solids. So what are the organic solids and inorganic solids you see here? So basically the inorganic solids, those are your mineral salts, you can say. Okay, so like your sand, gravel, debris, all those things are present, like chlorides, sulfates. Okay, so all those things in the sewage, those are your, you can say, as your inorganic matter. And what is the organic matter? So organic matter are, you can say, like carbohydrates, okay, such as cotton fiber, starch, sugar, fats, and oil. So all these things are organic. Okay, so these organic and inorganic matters are also present in the sewage. So now, how to find the these four solids in the sewage sample? Okay, so there is a particular practical experiment how you can find out the these four types of solids from the sewage sample. Okay, so number one, you can see here. Number one, you see, it is written as the total amount of solids, okay, and the total amount of solids, it is being represented by S1, okay, and the unit is in milligram per liter. So how will you find the total solids, total amount of solids present in a given sample? Okay, so it can be determined by evaporating a sewage sample. Okay, by evaporating a sewage sample and weighing the dry residue left. So you were taking a sewage sample and you heat it, and so heat it, and so the evaporation, obviously it will happen. So after evaporating, whatever dry residue is left, it is the mass of the residue divided by the volume of the sample evaporated. It will give you the total solids in milligram per liter. Okay, and it is designated as your S1. So you can see here the mass of the residue. So whatever mass is it is being left out, so it divided by whatever volume of sample you have taken. Okay, so if you divide both, you will get what, that amount of total solids. So next one is your the suspended solids. How we will find out? And the suspended solids, it is represented by S2. Okay, so you can find out by the same thing as in your raw water engineering also we have explained this. Okay, so you have to take a filter paper of 1 micrometers pore. Okay, so you are taking a filter paper, and then you are passing the volume of sewage through uh, this filter paper, and then you weigh the dry residue. Okay, then what is the formula? Like the mass of the residue, okay, divided by the volume of sample filtered. Okay, so you are taking a filter paper, then you are pouring the sample of sewage over the filter paper, and then you let it dry, and then you will get the residues that are left on the filter paper. So by using the formula, that the mass of the residue, whatever mass you are getting of the residue, you divide it by the volume of the sample that you have filtered. So you will get the suspended solids S2. Okay, that is in milligram per liter. So number 3 is your the difference between the total solids. Okay, the number 1, the total solids, and the suspended solids. So it will give you the amount of dissolved solids plus colloidals. Okay, so it will give you the amount of dissolved solids plus colloidal. So this is the formula. So this is your formula. S3 is equal to S1 minus S2. So if you do this formula, then you will get the this dissolved solids. So first, for finding the dissolved solids, you need to know the value of your total solids and the value of your suspended solids. Okay. So number 4 is your the total suspended solids. Okay. The total suspended solids, it can be either volatile or fixed. Okay. So, acha. So this number 3 point, it is not of that much importance. So first you should know these 3 points. Okay, suspended, then the total solids, and the this dissolved solids. Okay. So this 3 you write it down. Okay, this 3 A, B, C, you write it down. Then let me see. Okay, so then you see the settleable solids. Okay, settleable solids, how will you find out? You see the settleable solids. So it is written here that it can be determined easily with the help of a specially designed conical glass vessel called Inhofe con. So this diagram you can see, this is a Inhofe con. Okay, it's written here Inhofe con. So it is a conical glass vessel, and there are graduated scale. It is one graduated scale is there. This one you can see. This is the graduated scale. Okay. So the capacity of this cone, it is 1 liter, and it is graduated up to 50 milliliter. Okay, so what it is done, the sewage sample, it is allowed to stand in this Inhofe con for a period of 2 hours. So you fill the amount sewage sample here, and you leave it for 2 to 4 or 2 to 3 hours. Okay, then the quantity of solids that is settled at the bottom of the cone, so the some quantity it will be settled here. Okay, so you can easily read out the quantity of solids that is being settled out. Okay, and to obtain the precise or the accurate amount of settleable solids, the liquid from the cone, it should be, let it go. Okay, it should be decanted off, and the settleable solids collected at the bottom of the cone, it should be dried and weighed. So if you know if you let the water or the sewage sample to pass out through this bottom of the cone, okay, and when you dry the residues, okay, and then you weight it, so you will get the accurate amount of solids, how much solid is being being settled out. Okay, so this is your settleable solids. So next is your pH value. So pH, I hope everyone is now clear of as we have done it in your raw water engineering. Okay, so pH, it is the what? It is the negative logarithm of hydrogen ion concentration present in sewage. Okay, so, what did we study? Why we need to study about pH? Because we need to. It gives us an idea of the acidity, or you can say the alkalinity of the sewage sample. So, if the pH value it is less than 7. So basically, we have a scale chart of 14. Okay, 0 to 14, we have a scale chart. So if the pH it is less than 7, so the sewage sample is acidic, and if the pH it is more than 7, so the sewage sample it is alkaline. And the lesser the pH value, the lesser is the alkalinity. Okay, and then also just mm, okay, again the pH value, it can be, it can be quickly and it can be automatically measured also with the help of an instrument known as your potentiometer. If somehow you get a chance to visit our environmental lab in our college, then you will get to see this potentiometer. Okay, so in your environmental experiment this time you don't have, but later in 7th sem you might get the uh, lab of your environmental engineering. So that in that case you can see the potentiometer. Okay, so with the potentiometer you can also measure the pH of a sample. Okay, then next is your chloride content. Next is your chloride content. So chlorides, they are generally found in municipal sewage. Okay, which are what municipal sewage means, which are derived from your kitchens, like kitchens also, bathrooms also, like human excreta. Okay, all of then urinals and all those things in this sewage types. So your chlorides are found. Okay, so the normal chloride content, you have to remember the normal chloride content. It is your, you see here, the normal chloride content of domestic sewage, it is your 120 milligram per liter. Okay, 120 milligram per liter, whereas the permissible chloride content for water supplies, it was 250 milligram per liter. Okay, for domestic sewage it is your 120, and for what was for water supplies, it was the permissible chloride content for the raw water supplies, it was 250 milligram per liter. Okay, then next is your nitrogen content. Okay, so the nitrogen content, here also the same things. Okay, like free, it is the divided into your the nitrogen, it can be present in any of the four forms, like free ammonia, then albuminoid nitrogen, or it is also known as organic nitrogen, then nitrites, nitrates, all these four forms. Okay, so the free ammonia, what it indicates, the free ammonia, it is the very first stage of decomposition of organic matter. Okay, then albuminate nitrogen, it indicates the quantity of nitrogen present in sewage. Okay, before the decomposition of organic matter is started. So albuminate nitrogen, free ammonia, it is the first stage of your decomposition. Okay, first stage of decomposition of organic matter. Okay, then your albuminate nitrogen, it is indicating the how much quantity of nitrogen is present before the decomposition of organic matter has started. Okay, then the nitrites, it indicates the presence of your partly decomposed organic matter. Partly decomposed means the organic matters which are not fully oxidized. Okay, and then the nitrates, it indicates the presence of fully oxidized organic matter. Okay, so these are the four forms of nitrogen in which it may be present. Okay, so the nitrites, obviously we have discussed about mm, the amount of these things. Okay, how much permissible these four forms which should be present. So let us see the nitrates. Let me see, just wait. Okay, so for your nitrates, so what disease is due to nitrates? We have already learned that methemoglobinemia. Okay, methemoglobinemia is a disease. It is also known as your blue baby disease, and it happens due to it also happens in infants. Okay, so it happens due to the presence of excess of nitrates. Okay, and after this nitrates, let me see, these are all the same things that you have studied in raw water engineering. Okay, I don't think all the permissible limits are already given to you in the for this in your that class when we have done this for your raw water engineering. Okay, so the permissible limits are already given, so it is not discussed here now. Okay, it is not written here now, so you may refer to that one only. Okay, same thing. Then your presence of fats, oils, and greases. So greases, fats, and oils are these are derived in sewage from the discharges of animals, and all these are organic matter. Okay, these are organic matter. So these are derived from in sewage from the discharges of animals and vegetable matter that are present in the sewage that it produces from the kitchens. Okay, and then from the industries like garages, kitchens of hotels and restaurants. So from all these things, the you these greases, fats, and oils are derived in the sewage. Okay, so such matter or these fats, oils, and greases, what they do, they form a scum or they form a layer on the top of the sedimentation tank. So when without seeing the characteristics, you just these samples are passed to the treatment plant. So what it does, these layers, since the sewage it contains fats, oils, and greases layers, so it forms a scum on the or it forms a layer on the top of the sedimentation tank, and it what happens? It clogs the voids. Okay, it clogs the voids of the filters of the filtering medias. So they what they do, they actually it gives a barrier, or you can say they interfere the normal treatment methods. Okay, and hence this presence of fats, oils, and greases, they should be properly detected and it should be removed. Okay, so next is your sulfides, sulfates, and hydrogen sulfide gas. So here also the sulfides and sulfates, and it is sewage, it is from the decomposition, it is formed due to the decomposition of various sulfur containing substances present in the sewage. Okay, so this decomposition, whenever these sulfates, sulfides, and decomposition is happening, so hydrogen sulfide gas is being evolved. Okay, and hydrogen sulfide gas, it gives you a very bad smell and odor. Okay, besides also it causes your corrosion of concrete sewer pipes. Okay, it also causes corrosion. So uh, these things also we have done in everything. Characteristics, everything are same. Okay. Okay, so DO, dissolved oxygen, this one is a little bit important type of thing. So, the determination of dissolved oxygen, it is that is present in the sewage. Okay, it is to determine it. It is very important because while you discharge the treated sewage, okay, when you treat the sewage and you discharge it, you should be means you should have to you should be ensured that at least 4 ppm. What is ppm? Ppm is again milligram per liter. So 4 ppm of DO, it should be present in it. Okay, so if 4 ppm of DO, it is not present in the sewage, and if you discharge the sewage in the river, so what will happen? It will kill the fishes and the aquatic plants and animals in the water. Okay, so DO is a very important thing. So river, it also consists of DO. So this sewage, it should contain 4 ppm of your dissolved oxygen for in order to yeah, the fishes, so that they are not hampered. Okay, so then what's the time? Okay, so at the first step we take the attendance. Okay, so I think I'm also getting tired. So this from COD, we will discuss it in the next class. Okay, this COD and BOD. Okay, these are very important. COD, BOD, these are very important. So I would like to start these topics in a new class. Okay, so let us end it here today. Let's wait. Let me take the attendance. Roll number 1.
Yes, ma'am.
Okay, roll number 2. Roll number 3. Ardisha. 4, 5.
Present, ma'am.
4 is present. Okay.
Yes, ma'am.
5, 6, 7, 8, 9,
Present, ma'am.
9. Okay. 10, 11, 12,
Present,
13.
ma'am.
Yes,
Roll,
ma'am.
roll number
I'm 13.
14. Also, who said roll number 12 is present? Oinam is present.
Ma'am.
Roll number 11. Okay, Sanin is present. Then 12 is
Ma'am,
also
roll number.
present. Okay, okay. Okay, Oinam, I got you. 11, 12, 13 is present. Okay, then 14, 15, 16, 17, 18,
Yes, ma'am.
okay, 19, 19, 20,
Present, ma'am.
okay, 21, Wapan
21%.
okay, present. 22,
Yes, ma'am.
okay, 23, okay, 23 is written with attendance, okay,
Yes, ma'am.
okay, 23 present. 24,
Yes, ma'am.
okay, 25,
Present, ma'am.
okay, 26,
Present, ma'am.
okay, 27, 28,
Yes, ma'am.
okay,
Yes, ma'am.
29, okay, 28,
Yes,
29,
ma'am.
okay,
Yes,
29 is
ma'am.
also present, okay, 30.
Present, ma'am.
Okay. 31.
Ma'am,
30,
31 absent.
oh yeah. 32.
Present, ma'am.
33. Jodha Asim.
Yes,
34.
ma'am.
Yes, ma'am. 34.
Okay. 33 is present.
Yes, ma'am. Present.
Okay. 33 present, 34 present, then 35, 36, 37, 38, 39,
Present, ma'am.
okay, 40,
Yes, ma'am.
okay, 41,
Present, ma'am.
okay, 42, 43, 44,
Present, ma'am.
45,
Present, ma'am.
46,
Yes, ma'am.
47, 48, 49, 50. Okay, just listen the absent ones, okay? Roll number 2, 3,
Ma'am, roll number 2 present.
okay. Roll number 3,
Present, ma'am. Roll number 3.
okay. 5, 6, 7, 8, then 10, 14, 15, 16, 17, 19, then 27, 35, 36, 37, 38, 42, 43, 47, 48, 49. 49 is present over.
49 present, ma'am.
Okay. 49 is present. Then 40, 50 is present. 50. Then 47, 48. Yeah. 43 is present.
Yes, ma'am. 43 present.
Okay. Who else left out? 17. 17. 17 present. Now right. Okay. 17 present. Anyone else? 19. Major. Okay. Okay. Then 17, 19, 49. 49 to I have given just now. Okay. So I think nobody is left out. Okay. So I will provide you the PDF today. Okay. This PDF I will provide you so that you can note it down in your copy before your next class. Okay. So till then, okay. Then see you in the next class.